Perfect. Okay, so welcome guys to this video where we shall specifically look at a couple of things, including data types. Just a minute. Okay, so we can proceed. Sorry about that. Let me start a new project. In case you don't know, if you're using Eclipse, file new Java project, and it will open up this prompt. Let me see what we can call our today's. Maybe you can say Java basics. Okay. Then we click next. We can finish now. So when we do this, the project is opened up here. You can see it on your sidebar, on the left sidebar. So you can come under source folder. You create a new class. So now Java is an object-oriented programming language, so it uses the concept of classes and objects, and therefore you expect that you're going to be creating classes and then instantiating, creating objects here and there. I believe maybe over the next week we shall look at how to create classes and objects. This class I'll just highlight on that. Maybe I can, how can I call it? I don't want conflicting names, so I can say maybe teacher. So initially this public static void main was not checked, but I'm checking it because the main function, Java has this main function, so it's where all execution happens. Without it, if you execute, nothing will happen. So it's like the start of your program or the entry. I'm sure you've done C, you've done C++, you realize that they also those two languages also have the main function, and so that's the entry point to your program. Everything that lies within that class gets executed. Okay, so I will finish. When you finish, you have this code auto-generated for you. You have a class that we've created which is called teacher. You have a function which is created that we remember we checked that, so we said that the main function is the entry point of your program. And so now with Java, a class name must correlate or must be similar to the file name. So you see that the file name is teacher. Then of course Java programs have extension .java, so that's why you're seeing teacher.java, so that the file name is teacher. Now the class name must and the file name must be having the same name. If you for example put like teachers, you see there is an error because the class name must be same as file name. Let me first confirm if you guys are seeing my screen. Can you confirm that please?
So we are viewing,
cool.
We are seeing your screen.
Cool, yes. So the class name must be same as the file name. So that's why if I put teachers, it shows an error, or if you hover over it, it says that the public type teachers must be defined in its own class, in its own file. Now the public you're seeing, public is a visibility modifier, or what you can call access modifier. We have different access modifiers: public, private, default. When it comes to Java actually has 4 access modifiers: public, protected, private, and default. So public means that this class can be accessed in outside classes or outside modules. So that's basically what it means, or yeah, in your program. But once it's private, it cannot be accessed. Maybe you should have some time to, maybe in the coming weeks, and we talk about access specifiers. Okay, so today I want us to look at a few things which you must be familiar with. Data types. We are going to look at maybe comments. We are going to look at operators and maybe loops, just for today. Next time we can look at functions, methods, we look at arrays, we look at maybe classes and objects. Yeah, remember I'm doing a recap. So now for data types, Java has two types of data types. One is what we call primitive data types, and the second one is non-primitive. Okay, now for primitive, they are built-in data types. Okay, so we are saying that we have two types. One is what we call primitive data types, and we are saying that these are built in. Okay, so examples, whatever you're seeing, I've already started now comments. Yeah, now when you see two forward slashes, we use the two for single line comments. Okay, single line comments, and maybe later on I will talk about multi-line. So primitive data types, we said these are built in. Okay, they are built in with the language, within the language. For example, we have integer, we have double, we have float, we have what else we have short, we have long, we have byte, we have character, we have boolean. Okay, all these primitive data types. Next type is what we call non-primitive data types. Now these ones are created by the programmer. Okay, or defined by the user. Okay, created by the programmer, created by the user. Now not all non-primitive are created by the user, or you can say all non-primitive data types are created by the user except string. Okay, there is a primitive string, as you know. String, it's not primitive, it's non-primitive, even though it's not created by the user. Now so we are going to, for example, look at these. First of all, variable declaration, because for us to look at these data types, we must know how to declare variables. Variable declaration. So how do we declare variables? The syntax is you state the data type, then variable name. Okay, you state the data type of your variable and variable name. For example, if we have int and want to declare variable which is of data type int is for whole numbers, numeric values. Okay, so the data type in this case would be int, and then variable name, you choose any variable name that you want. Say maybe age, and then you say maybe 18. Okay, this is what we call variable declaration. So in this case we are looking at data type int, which is for whole numbers. As you can see, we have 18. Next is for double. Basically double, you can, so double is also for, you know, it accommodates both whole numbers and floating point numbers. But you can start with float. Float first of all is for, you know, decimal or numbers you use fractions, if I may call it. If you can say pi equals 3.14, you postfix that with, in Java you postfix a float with f. Okay, I think C# does the same as well. Yeah, so don't forget the f on that. So that's how you declare for example, float. Now for float, this is a data type that accommodates numbers with fractions, but specifically with decimal points, or decimal digits, 6 to 7. Okay, that's a different that's for a float. Like the decimals cannot go beyond 7. Okay, while for double accommodates both int and float. The amount equals 5,000 and you terminate. So for double, it also the difference between double and float is that double accommodates decimals. Of course, we've said that for both int and floating point numbers, but double accommodates decimal digits between from the range 15 to 16 decimal digits, which means that for double is able to accommodate very many floating numbers compared to float. So now we've looked at how to declare an int, a float, and a double. Now we proceed with other data types. We go to short. Now for short, the data type is short. The keyword is short, and then maybe you have variable. Okay, variable, maybe money, or it can be anything, So actually, the difference between short and int and float is that for short, it accommodates whole numbers, or it's for whole numbers, but between you first put it here, between -32 768 to 32767. Okay, so it's for whole numbers as well, but the number that you're going to assign to this data type must lie within this range. Okay, so we can say int c, for example, is 30,000. Okay, that's short, whole numbers, but between that range. Okay, but maybe before short we have another data type. I don't know if it's here. Okay, it's called byte. Okay, byte is also for whole numbers, but for a shorter range. Okay, so I can say byte equals, so I can say it's for whole numbers byte, but the range now also is small and compared to short. Its range is -128 to 127. So must make sure that, okay, let me first answer this. Okay, so you must make sure that the value you're going to assign in the byte lies within this range, and it must be a whole number between 128 to 127. Okay, then so we are done with int, double, float, byte, short. The next one is long. Now long also stores whole numbers, but it has a very big range. Yeah, it has a very big range. So the range is -99 223 372. It's quite a big number. Its range is quite big. So if you're very rich and you have a lot of money that we can't even count, your best data type to store your money that we can't count is the long data type. So that's you see the first value, quite a big number, 29223, and then 372, and then 036, then 854, 775, then 807. So that's the range. So you see it stores quite big numbers. So Now before I go to the other two, now if you look at this, you realize that all these are storing whole numbers, and of course, no, not all of them, except float. Okay, all of them store whole numbers except float. And so which one is the first? The short, the smallest is byte. If you look at the size, it's byte first. You go then to short. From short you go to int. You need to be knowing like which one is bigger. So the smallest is short, followed by byte, followed by short, followed by int, followed by float, followed by double, and then long. The difference between long and double is that double can store floating numbers, while actually double is bigger than long, because this even accommodates decimal digits or numbers. So yeah, so you need to be aware of that. Character, of course, stores a character, and it must be one. Okay, and use single quotations. Maybe you can say a. Okay, for character you use the single quotes. Boolean stores the Boolean values. Is human, for example, equals true. Boolean values, you have either true or false, so you use Boolean keyword. It's the one that is to store Boolean. So we've looked at how we can declare variables using different data types, particularly primitive. Yeah, so that's what we call primitive data types. I hope I'm too speedy. Give me thumbs up if my pace is good. Okay, there are very few. Give a thumbs, a one that looks down, thumbs down if I'm too speedy. I can reduce for you. Put the one that goes down. I'll be like, oh, okay, there's someone new. Okay, I can see that the pace is good. So now for non-primitive, we've said those ones are created by the program except the string. So for string, I don't confuse it. String, this string that you know is not primitive, even though it's built in. It's non-primitive. So we can say the name is, let me use my students. So we have Julia, for example. Okay. Yeah. So another type of non-primitive that is created by the programmer, or those primitive data types that are created by programmer. Examples are objects. Okay, objects. Okay, so what are the examples of objects? You can create a class. You can create a class and then instantiate it. Hopefully we'll look at that later, but I'm just going to do something small to demonstrate you how we create. Like I can say class. You can make it an inside class. We call it inner classes. So I can create an inner class. I say class teaching assistant. Since we are looking at chars. We will look at, you can create what we call outer classes, inner classes in Java. Quite many things there. When you say teaching assistant, maybe they have a name. This should be capital, and then they can have a function which says public void print name, and then we say, I know some of you are going to get lost here, but please follow up. So I've just created a class. just a demo class teaching assistant. We have time for creating classes, but I just want to show you how we create objects. And then you say I am called James. Okay, or we can even make it a constant and then we print. We can say James can make it a constant. make it just static. If we make it static, we'll be able to put the name here. Okay, yeah. So we have teaching assistant. Then this teaching assistant has the name James. Okay, we will look at what static means maybe later on, but I can even give a hint. Static means that the member of the class or the member belongs to the entire class, while if there is no static, it means that the property or the member belongs to an object of the class. So for example, if maybe I can give another that does not have, I can say string age, int age. Okay, now how do we create objects? You instantiate the class. So what's the class name? Teaching assistant. So you come here, you say teaching assistant, then the object name, then equals new teaching assistant. Then when you click over here, they are saying is not accessible. No enclosing instance of type teacher must qualify allocation with. Okay, what are we lacking? We need to prefix this with what am I missing out? No enclosing instance of type teacher must qualify. Let me see, are we missing out something? Oh, let me do this. Okay, anyway, I'm using a complex example, but I can create this in a different object and import it, but I can still use this same example to show you how to create an object. So we can say string name, this teacher, the class, say string name. Okay, the teacher has a name, and actually what we had created, let me just go back a bit, so I can copy this, whatever we had created, I put them inside here. Okay, I don't need even to make this static, and can say even this dot name. Yeah, I'm even introducing very many things at a time. Now I'm introducing this, but anyway, what I'm saying is that this teacher has a name, of course. This, remember, we call them attributes. A teacher has a name and has age, and of course there's a function inside the teacher class called print name. So how do we create an object? We use the class name. So you say teacher, the name of the class is teacher. Okay, so then you put followed by the object name, which is t, then equals new teacher. Okay, this is a constructor. We look at what constructors are. Then in this case you are able, now t is an object. Now you see, t, we are looking at creating objects. T is what? It's an object. You can give it anything else as long as it does. You can maybe say tr, any other name. So my object in this case is tr. So I say tr dot. If I say tr dot, you see I'm able to access the properties age and name, and even the print name, which is there. So I can say that 14 tr dot name equals Aina. Okay, so tr is a non-primitive data type. An object is what? It's a non-data type. So assigning the name and also the age. So I just wanted to show you how we create object. If I say an object, what does it, what is it? And an object is an instance of a class. So this is a class, then we are creating its instance, and it's tr. You can create as many objects as possible. I can create another one called t, then I say new teacher, and then this another object which is t, I assign it age maybe 18, and maybe t dot name equals femina, for example. Okay, something like this. So you see that you can create as many objects as possible. So that's what we also call non-primitive. Okay, so I have finished data types. Now let me talk about comments. comments are used in a programming language, so in your source code, to indicate basically what you're doing. It helps other people or other developers to read and understand your program. You see what I was doing here? If I'm sure you guys, if you follow this, you can understand what I'm talking about here. A non-primitive data types created by a programmer except string, something like that. You are putting comments, you're putting statements that other developers or other people can look through and understand your program. The same thing as, so used by developers to improve understandability of their program. Okay, program understandability of their program, or to make sure that other developers are able to read and understand their programs. Now, we said we have what we call single line comments. Okay, these are used to comment out a single line of code. Comment out a single line of code. An example, if I have int k equals 90, but I don't want this. Remember, comments, what you need to know about comments, they are not interpreted by the compiler, they are ignored. Okay, so if I say this, it will be ignored, and this is an example of a single line comment. Okay, next we have what we call multi-line comments. Okay, so multi-line comments, these are used to comment out more than one line of code, and we use which syntax? The syntax of use ****, then you put your comments here. For example, okay, Darlington is a computer science lecturer. I got next line. He likes programming and innovating, okay, solutions for the problems in the society. Okay, now if you have these, you see you have 3 lines of code, but you just want to comment them out, so you just do this, put /**, go where you want to stop at, then ***, so you can see. So this is what we call multi-line comment. Okay, whatever you want to leave out or not to be interpreted by a compiler, you can use this multi-line comment to comment out multiple lines of code. Okay, I hope we are flowing very well. So we can go to the next. In this case, we can look at operators. Okay. Now, operators, we have around 6 categories of operators. The operators, of course, they are used in a couple of things, in doing calculations, in comparing, in logical interpretations of expressions. So the first type is what we call arithmetic operators. Okay, arithmetic. Okay, the next type is what we call assignment operators. The next is what we call comparison, or what we call relational operators. Next category is what we call logical, and the fourth one, the how many? Fifth one is bitwise. Now if we are to start with arithmetic operators, these are used in mathematical calculations. Okay, used in mathematical what? Calculations. Examples: you have a plus, you have a minus, you have a division, you have you know, a multiplication, you have a modulus. Okay, so those, I'm very sure you guys are familiar with this. So you can just you know, use examples. We can declare and initialize two variables. We can say num1 equals 9, then we say num2 equals maybe 4. Okay, so in this case I've initialized. We looked at declaring here, and also I initialized. I declared initialized. Declaring is different from initializing. Declaring, you're just stating data type A and the variable name, while initializing you assign a value. Okay, if I can maybe separate this, let's say data type, syntax for declaration, then I'll come here and say syntax for for assignment. So the prerequisite to assign is to declare. So you would say data type variable name equals value. Assignment, you're looking at how to assign a value after declaring. So hope that is clear. I had forgotten about that. So in this case I've declared and initialized two variables, one num, num2. Now in Java, if we want to print, we use system.out.print. okay, there are very many. This is an overloaded method. Okay, if you can see it, there is print int, float, what or whatever you want to print, so it's overloaded. Then there is a print line. Print line inserts a new line after printing. Okay, so we can use print line. Maybe let me show the differences between the two. If we say system.out.print, I remove this and I say who is on the call. Okay, I can say Fred is a good man. Okay, Fred is a good man. Then I go next, I say print again. I say Fred, or you can say he supports a team that rarely wins, and that is Arsenal. Okay, so, and that is what? Arsenal. Now if we print, this will be in one line because it's just print, it does not insert a new line. If we can do this and we see the result. Okay, let me first select teacher. I want to view the console. Where is my console, please? Okay, did I minimize it to? Okay, why don't you come back here? Okay, so you see that if you look at this, Fred is a good man, he supports a team that rarely wins, and that is Arsenal. Okay, you see that there is no line, it's just one combined sentence. What? There is no, it's in one line. But if we use if we put LN, it will insert a new line, and so this one will be on a new line. He supports Arsenal, or he supports a team that doesn't win, or that rarely wins, Arsenal. Forgive me, Arsenal fans. So you see that it inserts that. Okay, Fred is a good man. Now it has gone to a new line because of LN. So I hope you see the difference between print and print line. Now the same thing if we come and say system.out.print and we say he is a computer science gem. Okay, so if you put that, whereas that this one will be combined with this because they are using print, so this one is not inserting a new line. Let's see. So you see he is a computer science gem, so it's one line, but the moment we put LN here and we run it, you see that it's now on a new line. Okay, so that's the difference between print print and then print line. I needed to echo on that. So okay, so now we want to look at our so I can put this one above, or we can actually comment it out. Can do this, use the multi-line comment that we looked at. So I want to perform arithmetic operations using these two parameters. So I will use system.out.print line, then I will say num1 plus num2 is, now we use a plus to concatenate, a plus. If you have like two strings and you want to concatenate them or form like one thing, then you use what? You use a plus. Maybe before let's specifically look what I'm saying. Assume we have two variables. One is a string first name, and we say Ronald. Okay, then I say string last name equals Nsimbi. Okay, and we want to form a name which is from both names, so you can say string name, so you concatenate the two, because if you concatenate the two, you form you form the full name. Okay, then you concatenate and say plus last name, and then you terminate. Do we have name already declared? Okay, up here. So we can say the reason as to why we have a name is red, it's because it's a duplicate. You must have one variable name. We've already declared it here. So what we can name this variable, we can call it for name, which is the concatenation of first name and last name. Now when you say system.out.print line and you say my full name is, then you come and say for name. Okay, then when you execute this, it will say my full name is Ronald Nsimbi. So this is what we call concatenation. You use this one to concatenate in Java. Okay, after talking about that, I wanted to demonstrate something, adding two numbers. So I'm concatenating, and so I'm going to add these two values, num1 plus num2. Okay, I terminate. I'm going to do the same thing for the rest, so I'm just going to copy this. Now that you understand what I'm doing, so then I move times, I put division, I use what is here, modulus. Okay, then here I change to minus, I change to multiplication, I change to division, I change to modulus. Okay, so a plus will add the two, a minus subtracts, a multiplication multiplies, the division divides, the modulus returns the remainder. Okay, so if we execute that, then we should see I'm rushing through this because you know what I'm talking about. We can actually instead of putting num1 num2, we can put actual values here, so we use the concatenation. Now how do I concatenate? I put two two quotations, then I put plus plus, then I put the value that I want, which is num1. I will do the same. I also concatenate here. You put two double quotations, you put num2. So this will just put the actual numbers. So since I want this throughout, I will replace that. Okay, don't want that. So okay, do they want me to copy one at a time? No, I don't want that. Okay, num2. So what I can do, I can use this, say num1, I say num2. These guys have like a control R, control H. Let me see. Just want to do something like this. Can I do this and just do this? Okay. Okay, seems it might be a little bit faster. So I'm trying to replace with the actual values. I'm just trying to concatenate. So instead of num1, they tell us which value of num1 is that exactly. Instead of saying num whatever, num2, num1, using so if I put this, that, this, that, okay. So if I print, they'll be able to tell us 9 plus 4 is 13, 9 minus 4 is 5, 9 times 4 is 36, 9 divided by this is 2. It's taking an integer, because the two are integers. Now if you get an integer divided by an integer, you get an integer. That's why it's this, because the two data types are what? If we get float here and then float, then we expect that we shall have a float, because you can see now it's 2.25. yeah, a float, and a float will return a what? Even when you have float int to return a float, but the moment you have int, then the result will always be int. Okay, so hopefully you've noted that on division. Then modulus, remember, modulus returns a remainder. So 9 divided by 4, it is 2, remainder 1, which is that value 1. Okay, so those are the arithmetic. Now for assignment, you know, they are used to assign values, assignment operators, okay, because e.g. we have equals, we have plus equals, no, plus, yes, plus equals, then we have minus equals, then we have what else we have? We have times equals, we have division equals, then we have modulus equals, etc. Okay, now this one, you're familiar with this, is used to assign a value. For example, assume I have boolean is good, then is good is a variable, okay? Then is say true, okay, because booleans are true or false. Now this equals is used to assign the value true to a variable called is good. Okay, yeah, so that's an example of false, then we say is Ayrton a good boy? Okay, then you come and say plus is good. Okay, my point is just on assigning. This is just to demonstrate the result if you want to print, so it's nothing much. My point is on assigning. Okay, so you see, is Ayrton good? False. Okay, that's what the program has said. So false is the value assigned using this equal sign to good. You have plus equals. Now if I have, let's say, int j equals 9, okay, and I say j plus equals 19, okay, this is same as j equals j plus 19. Okay, plus equals is same as, if you have a variable j plus equals 19, the same as j equals j plus 19. If you want to print the value, so I'm not going to repeat this since I'm now almost teaching prose. I'm just going to copy and paste. Please cancel that, paste that, and then I will say that the value of j is then plus j. So this would be able to give us 28 if you execute, and I say view console. That's why you see the value of j is 28, because j plus equals is same as j equals j plus 19. It is also same as if you have j minus equals 9, you know, it is equal to j equals j minus 9. If I have j times equals 7, it is same as j equals j times 7. Yeah, something like that. Yeah, you also including look at other operators. So that's basically how I've summarized for you assignment. Now for comparison operators, these are used to compare two values. Compare values, okay, not two, compare values. Now for comparison, we are saying that is it to compare values, and the result is always boolean. Result is boolean values, meaning true and false. So examples, you have equality operator, the one that compares to that tries to compare two values to see if they are equal. We have not equal to, we have greater, we have less than, we have less or equal, we have okay, we have less or equal, etc. Okay, now we can do just simple examples to demonstrate this. So we can say system.out.print line, and since we have j here, so we can add I don't know if we had used I, no, so we can use it. Then we shall say we concatenate our values. Okay, we put j plus, then here in between we shall put an operator. So we can say is j equal to, so it will be like is 9 equal to the value that we want to put, which is I. Then we concatenate to get the result. Then we say then we use this, then we add now we can put the expression. So if we say j, it will put the value 9 is 9 equal to I. What is the value of I? I is 8. Then here we expect a value, and which value are we expecting? We are equating them. Then here we shall say j equal to I. Okay, so if we execute this, it will put here, while there is I and j, it will put 9 8. So it will say is 9 equal to 8. Then here it will put the answer, which is j equal to I, and we expect it to be false or 0. Okay, so console, I see is why, oh, it's 28. No, it's 28 instead of 9, because we added here. When you say j plus equals 19, you're saying that the new value of j here equals the initial value of j plus 19. But if you want to use that, then comment out this. If you don't want to see that, run the program again. It keep hiding. So it's, you see, is 9 equal to 8? False. Of course it's not equal. Then I'm going to do the same, just going to compare and just change operators. Now the next is j not equal? This should be not equal. I say not equal, so there we expect a true, because 9 is not equal to 8. We can do them at once anyway. I will copy this, paste that, okay. So the next one is greater. Then here I put greater. Next I put less than. Then here I put less than. Here I put greater or equal. Here I put less or equal. Here I put this greater or equal. Here I put less or equal. What else have I missed out? I believe it's that. Now we shall run and see our program. So when you see the console, is 9 not equal to 8? It is true. Is 9 greater than 8? It is true. Is 9 less than 8? It is false. Is 9 greater or equal to 8? It is true. Is 9 less or equal to 8? It is false. Yeah, so that's basically it. These are what we called comparison. Now we have what we call logical operators. Now these logical operators, they return also boolean values. They try to compare expressions. Now if, for example, I have so we have two. We have and, the logical and, okay, this is known as logical and. Then we have logical or, this is logical or, okay. So an example is, you have two sides. When I say I want a student who studied math and physics, and is a keyword there. So then it means I need a person who studied both. If you come and you only did math, I will not accept. But if I come and say I want a student who did math or physics, it means I will accept a student who either did either one of those, and I even accept one who did both. So the difference is that for logical and, you must fulfill all the conditions for the result to be true. But for or, only you need is one of the conditions to be true. One, just one. The moment you have a true, it doesn't matter whether you have 1 million other conditions which are false. As long as you've gotten a true, the result is a true. So I will believe I can do a simple example. If I say system.out.println, and I say that so we are going back up. I hope you're not going to get confused. You will not. Okay, we shall say j plus, so we shall say greater. I'm just going to give you two examples. Other examples, I'm sure you will get them, but because these things are easy, so then j greater than that, then we shall say what is the result. The result has to be put, no, we still need more expressions. And this case, if you play around with concatenation, you will eventually understand it. In case it's confusing you, is j, now I want to concatenate this value, so I'll put j here, and I say is it equal to the value which is I. Okay, what do? I say add plus, then I put the expression here. So what am I doing? I'm comparing two expressions. One is j greater than I, okay, then I'm saying and the other one is j equal to I. Okay, so let's evaluate this expression together. Okay, now what will happen is that now we are trying to say is j, because if you say j greater than I and is j equal to this. Now first of all, we look at j. J is 9. Is 9 greater than 8? It is true. Okay, then we say and is j equal to I? No, false. What will be the result? True and false. Since it is an and, it will return a false, because for and to return a true, all the conditions must be true. But we are saying that j is not equal to I. They are not equal. This will return a false. So a true and a false will be a false. So when I run this, and this should restore this. Where can I restore this? Okay. You see that 9 greater than 8. Of course, this is true. But then and is 9 equal to 8? It would be false. Now I'm going to copy the same expression, and I use O. Now O, if one of them is true, it will be a true. So for example, you see that here this 9 greater than 8, it will yield as a true. Then 9 equal to 8 means a false. So for O, it will return a true, because one of the conditions is true, because 9 is greater than 8. So if we run, then we see, oh, I haven't changed the operators, so this has to be O. Okay, so if we run, it has to be true. So that's why it's true. Why? Because for O, one of the conditions must be true, and you can see that 9 is greater than 8. But for and, both of them must be true to be a true. So those are the logical operators. The next category is bitwise operators. This one is operate on bits. They operate on bits. So we have the bitwise and then this. So these behave like logical and logical. Oh, the difference is that they operate on bits. For example, if I say 1, which is a bit, and 0, this will be a 0. If I have 1 and a 1, this will always be a 1. Okay, if I have a 1 and O a 0, this will be a 1. So those are the bitwise operators. So I've finished operators. I've finished data types, comments, operators. Last day for today is what we call loops. I'm going to summarize these loops. So, but before loops, they're what we call, why do this in the next session? I believe so. I believe I should do this next session. Gives up a thumbs up. Give me a thumbs up if for next session. Give me a thumbs down if you want us to look at selection statements today. I like democracy. So you feel like this is good for today? Okay. I invite if anyone has questions. Let me not. I've seen that the problem we had with the other fundamentals is because there are 2 sessions and everything was covered in just 2 sessions. So people were like, "Hey, you mean you guys we are done with Java?" Some of you are like, "Hey, you mean like that we just finished Java?" Yeah. So Ronald, I see you've raised up your hand. Please come through and ask any question.
Yes, sir, well done.
Thank you.
When you were covering the print line and print, I discovered I've also used printf before in Java, so I'm asking what's the difference between them and printf?
The best way you can figure out is this. Let me show you. Okay. System.out. So you see the method signature. Okay, I like by showing you what happens. Now you see that the method signature for printf, it takes in 2 parameters. That is the string first, the next is an object. So this move for printf makes sense if you are writing like formatted strings. Maybe you have an object but you want like a formatted string out of that object. Okay, but if you're using print line, it takes in 1 parameter. If you look at the method signature, the overridden methods for print or print line, you see that it takes 1 parameter. I'm trying to see. No. I want to make sure you can be able to move through all of them. Dot print. Okay, you see the print takes in 1 what parameter based on the data type that you want to work on. Okay, double character, boolean. Also you can also print an empty string. So but for printf, you see it's also an overloaded method. 1, it takes in a string and the object argument, and it can help you to print that object in as a formatted string. And also next is this one. The next overloaded method is that, which takes in the local, the format, and the object. So it behaves in the same way as the previous one, just that now this one considers local as another parameter. Have you noticed the difference?
Yes, I have. Thank you so much.
Yeah, so it depends on what you want to print. All of them are used to print, but what are you printing? If it's an object and you want a formatted string, use printf. If you're just printing character, boolean, integer, all those primitive data types, actually now this is very for printf, it's very important if you're dealing with non-primitive, because for non-primitive, remember, you have an object, and if you want to print an object, a formatted object, as a good string or a formatted string, then use the printf. Okay, any other question? Any other question before we cross? Okay, thank you guys for coming through. See you in the next session.